Ooh, hey everybody, this is Larry. This is weekly contest 466. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. I'm trying to find my pen, so got my notebook, trying to find my pen, so alright, hopefully this is good. This is the live recording of me trying to go for the contest. There will be explanation video in its own video, so definitely wait for that. Without further ado, let's do. Right. I'm not working on anything like strategy wise. I'm just trying to get things right and hopefully get Q4 in a good way. I haven't been practicing well lately, but anyway. All right, we'll talk to later. Let's get started. Go. Do. All right. Recording? Okay. Numbers and choose any subarray and we play device another window. And we place each the bitwise n of all elements. I don't get it. Is it just whether all the numbers are the same? Right, so if right, you just take everything, right? I'm confused. Okay. I honestly, I would have missed the zero case if that was not in the input, but that's what I thought anyway. So okay, maybe a little bit lucky. All right, Q2. I feel like that's been a problem. Only a count. Yeah, I feel like that's a problem that we've seen before. It's just a max character, right? What? Or not max, but keep going, right? So it's just a, well, I mean, kind of max, but yeah, okay. Doesn't even matter, right? It's just S, right? Then it is going to be or C minus A, right? So that's the number from A, and then you want to minus 26 from that, because if it's Z, then it'll be 25, and you have 1, and then max of this, right? Come on, like that. 2, 0. Let me double check. So that should be 25. It should be 26, right? So, okay. Honestly, nowadays I'm so much less confident because I'm just not as practiced. But okay, pretty okay. Let's do Q3. Numbers of distinct elements, so we'll go if 3 elements are minus L plus 1 is greater than equal to 3. The minimum of the 2 ends is strictly greater than the maximum of all numbers. Okay, so like, okay. So this is probably like a mono queue, a mono stack thing, right? Maybe. Let's see. So 2. So at least 3 elements. How do I think about this? So 4, what am I doing? So then I would want to go back. It doesn't have to be increasing, but here, all the numbers are in between the 2, right? 3, all the numbers do. 2, that's not true. So then monotonically increasing from the back. Yeah, so like I said, it was going to be monostack. I thought it was monostack, but I just want to go confirm it. Right? Is it equal? If it's equal, we strictly greater than. So then you want to remove it if it's equal. So yeah. But also maybe something like that. Right. 230. That's not right. So 2, no, 5 and 2. Oh, it has to be at least 3 elements. I missed that part. Oh, I didn't miss that part, but my implementation does not consider it. And also, is it accurate? I think this is actually beforehand, but I have to subtract out. What do I have to subtract out? The 3 element case. Right? Yeah, okay, fine. And the top of the stack, the second element, say, is equal to it's gonna be the index. So then if index minus, if this is equal to this plus 1, then we can subtract by 1. Okay. Why is this 1? Oh, because here it thinks. So I'm not quite right. Though I think we still want a monotonic stack, but that's not quite right. I think the idea is mostly right, but some part of it is clearly not. Basically, look at here. It thinks that everything in between. You have to do a binary search on. Okay, because basically the biggest number, or the number that's bigger, once it gets to the bigger number, then everything after that cannot be thing, because everything in between would not be smaller than the min. Okay, so that's a little bit annoying, but that's fine. How do I write it? Because you can't just do bisect left because of this part. Maybe we do it backwards. Can backwards work? No, this is symmetric. It shouldn't matter. It's just that this is monotonically decreasing, which binary search is a little bit annoying on. Alright, so we get rid of this for a second. Here we do, okay, so count, you go to so we want this to be, if it's equal, is it fine? If it's equal, it's fine. And we can take care of this thing in a sec. Actually, it's so annoying. Okay, I just say we swapped left to the right, so that now we bisect left backwards. No, that doesn't make sense. This is not a hard problem, but it is annoying to write. Okay, fine. this number is bigger than x and we want to move right, no, then it could be valid. Could be valid, actually, yeah. Else, then if it is smaller, greater than, or equal to, well, in that case, it could also be valid if it's equal to. So then y is equal to minus 1. Okay, and then now count is going to be equal to so then left is the index, so then it is going to be length of stack minus left or something. Could be plus. It's very annoying. I think this is fine though. Other than that, but now we don't want this. We want x is equal to num sub. So then we could do one turn behind, I think. If it is exactly the same, do you want to? Yeah, because you can still remove. So okay, so this is fine. But I think this part has to be that. Well, no. I guess this is technically inclusive, but all right. I think I'm right, but it's just getting it correct is a little bit messy. All right. Print x stack left. Total as well. Okay, 2 has nothing, 5 has nothing on the stack. You put the 2. Oh, I wanted to do something like this, but I guess it doesn't make sense because then now it thinks that this is 1. Because I was trying to do this with a delay thing, but you need to pop these off, and this doesn't get popped off if it's delayed. So okay, fine, right? Okay, so then maybe we do something like Alright, well let's just run it real quick just to make sure. Okay, that's just really off. 5 match 2. Oh yeah, that's why it's off. No, because you always do. I always subtract 1. I don't know. This look feels hacky though. Also, this has to be before you add. Even if this is right, it feels hacky. The reason is because the last element you add is always going to be the top element. So that's probably the reason. But honestly, I'm not confident, but I want to YOLO it a little bit. Okay. Because that logic, honestly, is a little bit shaky, that logic, but worked well enough. 10 minutes. Not that bad along. Oh, 1300 ranking though. Well, we could get this one maybe. So let's take a look. I actually didn't even look at the rankings. I just kind of saw my time. Okay. Non-negative number n. Binary palindromic. If it's binary, reach the same way back and forth. Return the number of. Okay. N and the binary up. K such that, okay, so, and n can be, oh, pretty big even, 10 to the 15. So it's just 0 to 9. All right, let's think about this. All right. I guess it cannot be even because there's no leading zero. So, but I just want to take a look real quick. Because this is 9, 10 obviously no good, 11 no good. Okay, so then we can do maybe like if I'm just trying to establish some pattern, to be honest, just to kind of get me started really, but because I mean they'll be the same anyway. And 15 makes sense. Then we can construct this, right? Oh, what count 0 actually? Okay, I mean we do count 0 in this case, but okay, so I mean it's just taking the first half and then seeing whether they all fit. That could be pretty big though, because 10 to the 15, so that's what 50 bits. 50 bits is a lot. Well, even 25 bits for half of it is a lot, right? So we have to be a little bit smarter than that. It's probably just digit DP, isn't it? Yeah, it's probably digit DP. How do I do a digit DP? Right, and there's no, I'm surprised they didn't do a range one, which is like left and right. It's just n is 0 to 9. It saves me like, I don't know, 20 seconds or something. Okay, so it's probably digit DP because it's 50 elements. That's fine, right? Yeah, okay. I mean, I'm so every time I do digit DP, I feel like I'm rusty, but I think that's probably it. Okay, so I always just put them up, right? Okay, so actually we want bin of n. Let's say string, right? And then now we want to say yeah, nothing crazy, right? Dealing with s, so size is equal to this, and then this is, I usually just do it by case analysis actually. So then this is just all numbers with smaller than Sn is good. So let's just sum it up. Total 0, 0. Is there no mod? I guess not. I guess this fits in long because well, that's the upper bound. Okay, right? So yeah. So for I in range of SC doesn't include SC. Let's just say I. Okay. So then this is, yeah, just cache it, right? Or pattern geometry or whatever, right? Okay. So then how does that work? With x digits, right? So if x, let's just say was 0 to 0, we just return 1 was 0. If x oh, it's binary. I forgot it's binary actually. I was like, something feels a little bit weird, but okay. If x is equal to 1, that's 1 digit, right? If x mod 2 is equal to 1, so if it's odd, I guess then in this. Is 0 1 digit? Maybe it is. And we just don't count the 0 digit. I don't know. I don't know which one is better, honestly. I mean, this should not happen. I don't know. Honestly, I think that may screw me up later, but we'll just keep this for now. Maybe add it to do. Okay, so then if it's odd, let's just do it's even, right? If it's even, then what? You have x digits, then it's x over 2, so then it's just return power of 2 x over 2, right? Pretty straightforward. If else, then is power of 2 x right? Times 2, yeah, right? Pretty straightforward actually, except for maybe 0 case. So I'm thinking about the other recursion for now, so that's why. Okay, and in fact, though, this gonna be cached on all the problems, so we'll just put it here, right? Okay, and then now this is the okay, so then now I know some people have template for this, and honestly I'm not that good on this one. Okay, so we have an F that does, what do we want? We have an S, let's not put it in there. We have an index, we have whether it satisfies the prefix, or we're on the prefix check. I don't know how to do half of it though, or you have to do like both halves, and I think that's the part that I have to think about. Is that sufficient? I don't know. Okay, so then now oh, and whether we have a leading 0, so we should be fine. We'll just have to do we have to start at 1. The first digit is always 1. Prefix is going to be true for now because the first digit is always 1. But I still don't know how to do the suffix though. Maybe I have to think about this a little bit on the prefix, on the digit DP. Did I do the digit DP backwards? Would that help? I don't think so. I don't know how to do it forward. And you can put the 25 things on the space, right? I actually don't know. How do I keep the constraint on the prefix and the suffix at the same time? Okay, so maybe it depends on the input. If it's 0, then it doesn't matter. So given so if it's a 1 and you go over, we have to do the previous. I think I need to draw this out honestly, but I'll try to do my best here. But you have something like this, right? So that's a palindrome as an input side, but then now you have this. That doesn't matter because this has to be 0, that's fine, but whatever, you have this. Oh. Can you have a 1 here? Does it depend on the other stuff? Let's say you have 1, 1 here. Can this be a 1? yes, right? Because then that means that you have 0, 0. 1 is fine, right? So then now it becomes a case analysis, I suppose. How much time do I have left? An hour? Well, people got it very fast, so maybe I'm just doing it in a silly way. Like I think I could case it out, but it's definitely not a easy one, right? Because if you're basically saying if the rest of the thing has a 1 and we have to set it, because if it's all zeros until this one, then it doesn't work, right? So we have to basically have a 1, like required or something, maybe like a need. And this technically is true. Well, you only need a 1. Yes, because if it's always zeros, then you don't get it. You only need a 1 if the last digit is a 1 in this case, right? I don't even know. I'm just going to write something real quick because I don't want to deal with edge cases. So then now is if n is less than 100. Yeah. Does it go to 100? Okay, I just say 105 then. Did I delete that code? I guess I did. Okay, so it works for. Well, okay, I guess it has to do some other stuff first. Is that right? Yes. Oh, we got it. Whoa. Do we not have 0? What? How did I now have to debug this? Why? X in small, x is less than equal to n. No, that's right. Wait, I output 1, so why did I just look at it wrong? Oh, I looked at the input and I thought that would, okay, so this is why output, this is right, okay, fine. Okay. Because then now I can do things with double digits, but this is if s of n minus 1 is equal to 1, then you need 1, right? Okay. A prefix. I guess it always matches the prefix because otherwise then you just go whatever you want, right? So maybe the prefix is always going to be true. I'll keep it in here for now, but I think I don't need it the way that I wrote it out into a different function here. But okay, need a coming 1 to make the future true or something, whatever. Okay. Okay, so I is equal to n mod 2 equals to 1, right? So, okay. So let's say m is equal to n plus 1 over 2. So if it's 3, it will give me 2. Okay, that's right. 0, 1, 2. No, if it's 3, it's 0, 1, 2, and it'll be 1. Will be the, no, then after we want it to pass 1. Right? Yeah. We want it to, so we want 2. Yeah, no, this is right. Okay. And actually, I don't even think we need the odd part. It's just because you just flip it and it doesn't matter. Maybe. Okay. So then, okay. So if need, then we return 0. Otherwise, we return 1. I think. Otherwise, okay, try a 0, right? So if s of index is equal to 0, or is equal to, I guess we can always try 0, but it's whether, we can always try 0 for sure, right? But what does that mean? Index plus 1, okay, prefix. Yeah, I guess this part has to be whether s of index is equal to 0. And then you pass along the need, I think. But you have to also do that. No, I mean, I guess you don't have to do the other side, right? Because you always satisfy both sides, really. It's just whether it is the prefix or not. But then what are we tracking with prefix then? Oh, we're tracking whether, okay. Because the prefix is false, then we can just use the other function, right? If not prefix, then we can return. Oh, but the need part makes it maybe prefix is needed. I don't think so, honestly, still maybe, but we'll keep it here for now. I think it's okay to not simplify yet. Okay, so if s index, okay. Now then, this is actually not necessarily right. It's going to be prefix and this, right? Because then it just keeps going. So if it's prefix, then you keep going. Otherwise, try 1. Okay, so if prefix, then if s of index is equal to 0, then we can't. If s of index is n minus index, minus 1. If this is 0, then what happens? And this is the thing where we need, right? We need a thing in the future, right? So new need is equal to true. Yeah. Okay. I mean, it actually satisfies the previous need, but so it's something like, okay. So okay, so if it's 0, then new need is equal to true. right? Otherwise, then now we can say f of x plus 1. The prefix, we still have a, well, if it's 0, then we just can't. If this is true, we just do true. Now this pass is wrong. So maybe okay, and then now if this is an else, okay, so if it is a 1, then new prefix is just true. Maybe. If it's a 1, then we just don't care, right? Because we're putting a 1 anyway on the other side. Okay, so then now if it's good, go to the next number, new prefix. Yeah, we don't care about this. So decided this. I guess this has to be one or the other, but I think the way I wrote it is fine. And then you need, right? Because it actually flips off the other one. But then now we need a new one if that's the case. Otherwise it's false. Okay. So if it's not prefix, what happens? If it's not prefix, then we could do whatever we want, really. Right? Then we do total f of index plus 1. It will never be prefix again. Need is always going to be false because we satisfied the previous needs. And then we are good, hopefully. The problem is that, like, these problems, I wish they give like just one big case, right? Okay, that's at least good in a way. What I actually want to write is also force, right? Then now I can write right, I said right, I think actually. List had, oh yeah, right. New. Oh, not S, but N. Okay, this line is alpha. Oh, it's not N minus 1. Oh, it is N minus 1 though, but huh? Why is N minus 1 would return, will be out of bounds? Oh, it's the size. Whoops, I forgot that size is, okay, fine. Easy fixed. And that's the same thing here. String out of bounds. Okay, why? Do I not have a base case? Try 0. We have a base case. Is that not right? Index. I mean, M is strictly less than N, so that should always just be right. Oh, it's, I keep on doing this everywhere. Okay. Okay, so the actual answer is 62. We have 105. That's no bueno. Let's try 100 actually. Okay. Let's just try with these 3 numbers. No, I guess 100. We hard coded it. And I just do 500. I mean, we're still very wrong though. Ow, hurt my knee. I'm old. Just sitting incorrectly. Okay. How much time we have? 50 minutes. Hopefully that should be enough. So we're over counting, right? Okay, so we're over counting. So something is off with this. Let's turn this. This is if I need a number. Yep. This is where the prefix is true. It's always going to be true of the first digit. Or after the first digit, right? So this is over counting. Why am I over counting? It is hard to debug. New need, if it's 0, then, and we want to put a 1, then we need it. Yeah. I mean, try a 0, we try a 1, so we don't really do anything too funky. Hopefully, the prefix is forced. That's true. This is true. Okay. If I mean, I thought I would be undercounting, honestly, but this is forced, then we just do. It doesn't matter if we try 1. If this is forced, then we just keep going, right? So that means that we do both if the prefix is forced. So this should be right. The prefix is forced. It is 2 to the remainder bits. Did I do the thing wrong? Maybe this is. We have 3. We go to 2. Try this real quick. I mean, it's closer, but it's still off by a lot, actually. So I don't think that's quite. So it's probably this part. I mean, this card cannot be wrong, right? We could just even print it, really. This one, I mean, I guess that's helpful, but also maybe not that much. I mean, I believe it. The code should be pretty tight. All right, so what am I missing? This part is too liberal. Is there any other case where we force a need? This is the one, so. Well, the need doesn't do anything. We don't. No, the need does something if at the end, but that's it. And all we need is a 1 after that, right? Let's put force less than 10 for a second, and then maybe we can debug the smaller number. Okay, let's debug 15, say. 7 and we have 9. What is 15 again? We can print this more. It's like the title of this thing, which would be funny, actually. X is that many digits. Each digit could be popped in. No, this should be right. Math could be cleaner, but it should be right. Okay, so 15 we have 7, and I put 9. Why do I think it's 9? This is so annoying because I feel like I'm mostly done, but yeah, well, it is what it is. All right, index. What's it? Prefix, need, total. Expensive debugging. 1, 1, 1. Then why is it 9? Okay, so what is this returning? So it's counting. Okay. Maybe it's here actually. That'd be funny if that is true that I was here. I mean. Okay, so what is the 7 from? Oh, the first. I have no idea what this 7 is from. Oh no, it's this 7. But this is already 8, so we're definitely already wrong. That's fine though, right? Okay, 1. Oh, this is the number of binary bits. Oh, I'm doing size instead of size over 2. I am dumb. Okay, that's an easy fix. I think I'm maybe off by 1, but that's an easy fix anyway. Maybe. But that was definitely wrong though. Okay, I have to think about it for a sec. So if it's 3-digit, we want 0. It was 3-digit, then 0. Then we want up to 2-digit of good things. 1-digit. Well, we want, so then just 1-digit. So then it goes from 1 to 2. So it's 3 digits. Then now we're 2. I think this is right, or this other one was right, maybe. Okay. Well, I think the answer is 2. I am dumb. Okay, so the 4 digits. I'm dumb. I made the same mistake like in so many places. Okay, so it's 1, 2, 2, 4. The 2 seems is 2 wrong? 0 is just wrong. We don't want 0 anyway. So then it's just, but 2, 2, 4 is definitely wrong. Right? 2 is 2. We have 2 digits. Oh, I did it in a weird way. I want half the digit, so this is actually just, oh, that's why. Okay, maybe that was right actually. Though it's very awkward. So then now it's 4, so then it's 2, 4, 2, 2, 4, right? 1 digit is gonna have 2. 2 digits is 0, 0, 1, 1, 2. 3 digits is 4 is right, so this should already be 8. Why am I at 7? Well, why is the real answer 7? Am I, well, like this is the real answer, but Oh my. I have 41 minutes. I should be able to solve this, but I'm just being dumb today. Okay, so 1 digit. Oh, 2 digit is, oh, 0, 0. There's no leading zeros. There are no leading zeros. And also you can just do 2, 2. Okay, so we assume the first, okay, okay, that's tractable, right? Okay, so then, okay, so that actually solves this part that I needed to do. Okay, so then now the first digit is a 1, right? So then now you have the first and the last digit is a 1. So then you have x minus 2, 3 digits. And then, yeah. If this is a 1, what happens? You have 1 digit. if there's 2 digits, then it's I guess just this plus 1 really. So I don't need this. Maybe because having that as -2 is awkward. So maybe we still need it. What's the answer we're looking for? Oh, it's 7. Okay, I mean, so 0. Let's see. Okay, maybe now a of 0 matters. We have 7 just from these, and then I do one more, and that is where it comes from. How many digits are there? 4. So there are 4 digits. We have 1. True, true. What is S anyway? Oh, this is S. So true, but the need is not true. This should be, if this is 0. I don't know how I messed that one up. Okay. And the answer is 9. Is the answer 9? No, the answer is 7, right? Because we have 1, 2, 3, 4, 5, 6, 7, right? But some of this is wrong then, because this is already 7. We have 0 digits, 1, 2 digit, 0, 1, 2 is still 2, right? Why is 2 2? Because it's 0. Power of 2 to the 0 is 1. Okay, 2 to the 0 is 1, I suppose. Maybe I don't need the plus 1. Maybe I just... Yeah, okay. I believe that. Alright. I got this one right. Let's try some bigger numbers. Okay, maybe without all the printing. This one's actually probably fine, but we'll still take it out. Okay, still a little bit wrong. Off by a couple. 7 is right, but everything's off by 2, which is maybe okay if it's consistent, but I don't think so. So, that's actually very sad and annoying. Okay, so we're at 15. Let's go back to debugging. Let's say 17. What is the next number after 15? Oh, I guess 17. Okay, let's try 100. I think 100 was the incorrect one anyway. We have 18, so we're undercounting. Why are we undercounting? We have half an hour. Man, I'm never solving any of these anymore. I'm just like so bad these days. Okay, so this is 100. 100 is 20 bits. What? Was that from a previous problem? Maybe that's from. No, that's. Oh no, 20 is the right answer. Okay. Okay, 20 is the right answer. This is S. So then now the prefix with 15 from 0 to 6. 0, 1, 2, 3, 4, 3, 4, 5, and then 6. Right? I don't know what that means. Alright, this probably tells me this is right. It's probably right? 15, okay. So then it is based on this. 6, 6, this is 7. So 7 has 5. Well, up to 100 anyway. I guess it goes beyond that, but I only put 3. So it's definitely on the thing. Okay. Yeah, we don't need the other ones for now. Maybe I'm not getting it. Maybe I thought I was getting it, but not getting it. That would be sad. Okay, so we are index 1. True, true. This is 3. Okay, 2. So it goes true, true, and 0. Okay, I guess that's true. Yeah, you can have any with this prefix. Okay, so I think this is correct. But then, okay, so 3. Okay, so 1, 2, 3 is force. If it's force, then it should be. Oh wait, this is true 2, which is true. Okay, that's fine. This being 1 is also fine, I think, because you need a 1 to balance it out, I suppose. Do you? No, if this is force, this should be, doesn't matter. If you are force, okay, yeah, maybe this is wrong. The prefix and need. Is that true? If it's anything you want, then no, by definition, if it's anything you want, then you have anything you want. Okay, I'm still missing 1 though. There's only 2 degrees of freedom. No, they're not more than 2 degrees of freedom. Well, this has to be a 0. Because if this is a 1, no, if this is a true, we can have 2 true is not giving me a true. Is this the right thing to go by? Maybe I'm missing one because it should. No, this is right. But this is wrong though. 3 true. Oh wait, no, because it's 1 0. This has to be a 0. Okay, so maybe that's right. But why am I missing one? What am I? Number am I missing? Okay, so this is good. Oh, I'm missing this one for sure. Yeah, no, I'm missing this one. I don't mark it as right. So okay, so it's true. Then what? It just has to have a 1 before. I thought it has to have a 1 here, but this. Oh, how do I handle that? Because this 1 means that all these could be. Oh, so that means that. I see. So there's a need, but there's also last 1. I see. Okay, so okay. If there's a 1 in the opposite thing, then you need is okay. Let's see. Okay, so this is true. But if this is a 1, then we actually also set the force, which in this case will be force anyway, but in this case, I might not, right? So basically, in this case, new need is equal to need, but if this is a 1, this is a 1, then we actually set it to force for anything, really. Well, this can never be happen, and then it's force in the other cases, right? Wait, I don't call it. Wait, did I make a mistake? I mean, okay, yes, okay, come on, second chance. Yes, okay, but is it right for the other cases? Where's the reset test cases? 100, 15, 1,000, 1,000. I just want it real quick. There's too many print things. I don't know what the right answer is. I have to prove force code, so it will tell me. Okay, so 2762 is 205. All right, we could even try one more for good luck, because we counted to 1,000,000 for some reason, I think. 1,000,000 or 100,000, I don't even know. Okay. Yeah, I mean, we're almost done, so might as well. Oh, 2,000 to, that's actually kind of coincidental. Okay, let's remove this, and then let's remove the okay, that's also, I guess we could keep the print, but it's fine. Let's remove it anyway. And then let's make this 1,000, why not? No big deal. All right, YOLO submit. Did I not? 200 is sad. 100 is right, but 200 is wrong. It's very annoying, actually. Did I not print? I just thought I could print. Oh, am I just dumb? I changed it to 1,000, but then my small is only a, okay. That is the dumbest mistake. I was like, why is this not printing? Okay, well, okay. I mean, at least, you know, that's a real wrong answer and not a dumb wrong answer. But that's actually sad, though. We have 26 minutes. We should still be able to figure this out. Hopefully, it's a long time. But yeah, but we're definitely off by 1. We're over by 1. What are we over by? Because 1,000 is right. Right? Trying to find which one am I over counting. I guess 60 is 62, right? I was hoping to not mess with it, but I guess this one. 62 is right. Okay. 94 and 93 we overcount. What do we overcount by then? Oh, this is because of if itself, maybe if it's not digit thing. If index is not equal to something like this. Because I forgot that I have that case. Okay, that's it actually 110 is somehow right, but we undercount and then overcount and overcount again, or overcount, undercount, overcount again. Okay, so that's on 200 or 2000. Sorry. Let's binary search this. No, but I'm just trying to figure out like what is it overcounting on. 70. So we overcount at 1500. What number are we overcounting on? Okay, let's see. So easy way to do this, the way that I did the caching. Here's so annoying. Off by 1. This prefix is always happens if need. And then it clears everything out because if this is a 0, it clears everything out. And this is a 1. And well, we're overcounting, not undercounting. This feels right, but am I missing a case? No, am I clearing something that shouldn't be cleared? I guess that's the question. If this is false, it doesn't change. If it is true, it only changes if that is true. Or if this current thing is a 1. Oh yeah, wait, but the current thing is a prefix is a 1, and this would just be false anyway. Is this still needed? Maybe that's why. Maybe I cleared it out correctly. Nope. No, I am still wrong. Man, this is frustrating. Alright, let's just binary search this. It's not binary search, but it's close enough. 22 minutes. Oh man. Even when I'm almost good, I am not good enough. 72, 75, 70, so 1500. So close. Maybe. Yeah. Wow, we're even off by a bunch in some of these. So okay. Why is that? That's actually off by a lot. Like this should be continuous, for example, but like all of these are wrong in some weird way. Okay, so maybe we won't get it. Maybe we're just off by a bunch. Okay, so it's not the first 2. Okay, so I'm really off by the time it's 1440. There's so many digits, I don't even know how to debug this, honestly. Am I like off by 1 on size or something weird? Why would it come up only when... I mean, this is 76, but then it gets smaller. What the... There's probably a way I could write a for loop about this, but all right, that's good. Also good. I guess I should have written it offline because I don't have a good setup here. But clearly this is wrong. So it's not the first three. Let's just remove the first two. What is special about this? Huh? This thing, we have 11 digits. So the middle digit being a 1 maybe? Maybe that's a thing? Because I don't know that I know how to handle the, oops, what happened? Okay. I don't know that I know how to handle the middle thing being a 1. Because I kind of just in this case we're undercounting, and in the future we're overcounting. It's off by like 2, not even off by 1. How? It's this middle thing. Okay, so now we moved that. So it is definitely like the weird middle digit thing. All right, so maybe we have to think about, let's just handle it, right? So if, okay, so then now let's think about all the cases. Maybe that's what we have to do. Okay, so then now within the middle digit, if not prefix, then it can be 0 or 1, right? And we just yeah. Let's just do it this way then. Do I need it? I guess it's true and plus. This is, well, it's not always true, but it's just input technically speaking, but it doesn't change anything. Oh, well, maybe it did. I did change it. So if it's 0, then it doesn't change the need. Yep, okay, fine. And then this is a 1, so then now it's at force and force, right? Okay. Else. Okay, else is a tricky part, but that's okay. So if it is the prefix, if s of index is equal to 0, then what happens? This is actually base case, I think. So if need, then this is, if not need, then we increment. I guess we should convert it to be a base case instead of some weird case. And then, okay. Okay, so given the prefix, we have s of index is equal to 0. Okay, then that means that this has to be 0. There's no way around. Yeah, there's no way around it. And prefix is always true, so oh yeah, we don't have to write this out. So that means that it has to be 0, so increment by 1. Else, if it's a 1, then it could be 0. Okay, and then it could be a 1. If it is a 1, then need is becoming, oh wait, we have to care about need. If it's 0, then if not need If not need, then we have to put a 0, right? Else, then we could put a 1 because it's a 1 and that's fine. So then and then I think this is fine. Yeah, maybe. Nope. So maybe that's not, this isn't the situation then. Well, this isn't the case, but So the title, I'm just doing this wrong. If this is a 0. If it's not, we don't need it. I don't know how this could be though. If this is not prefix. No, this is wrong maybe. Maybe I'm just getting this part wrong. Okay, maybe. Because if it's not needed, I think this should be still not prefix. With prefix and this then. Alright, well, let's try to. I can't believe like it passed all our random tests, but not actually all of them, obviously. Like we tested a lot of numbers, but and we just got lucky. 902. Okay, so we still have some wrong things. So that's a little bit sad for sure. Maybe I just don't know. Maybe I'm clearly missing like a little bit of my logic. I think this is needed though. No, prefix is probably right, or I don't know how to debug this. I mean, it's probably another thing where, you know, the middle bit, I overcount maybe. Alright, let's just see, try 0. If we try is this ever needed? Maybe that's it. But we're overcounting, so that also doesn't change the answer somehow. Well, change the answers to these, so maybe it isn't necessary. But that means that this is probably necessary for consistency. So I don't know, but then that means that the other things are wrong. Oh. Did I do anything else wrong? Maybe I won't get it. It is very frustrating because we're so close. And 11 minutes, I don't think I have time to reset. I feel like that's how I've been the last couple of contests, is that I've been so close, but I'm just a little bit off. Why is this we can't again? So try a 1. Oh, we can't try a 1. Okay, that's fair enough. Else we can. New prefix is true. Isn't new prefix always true? I guess so. Because, yeah, because it can only do if the prefix is a 1. If this is a 0, then, and we have a 1, then we need a 1 somewhere in the future. Is that true? Is that why I'm overcounting? Because the idea is that if we keep the prefix, this is still going on, right? So we have a 1, 0, but then you have 1, 1. I think that's maybe it, but how do I represent? How do I say that in a good way? Okay, I mean, I think this part is maybe right, but there is a thing where you just because you have a 1 here, you don't erase it because you don't take advantage of it. Because if this is a 1, then it's still true. Like the old one, rather. I mean, still not right. Now we're undercounting. Is this right? Honestly, I don't think so. But I am YOLOing because I have 8 minutes. Right? So why not? It matches, right? So why not? Why not? I think I don't even have to remove this. It doesn't really do anything, but I don't think this is right though, because we just kind of. I don't know how that's right. I'm just kind of happy. I mean, why is this? Like for symmetry reasons, I don't get why this is right. I did realize that this part I did mess that up, but and I was honestly 100%. I was YOLOing because I mean, what else I have got to lose? But I don't. It's very weird for sure. Like I don't. Like what? Why is it? Because if you have a, I mean, maybe there's something with the. Oh, because this is a one. No, it's a prefix. Oh, this is because you can free to do anything. But if you're free to do anything, and you still need a 1, why would giving it 0 help? I honestly don't get it. Like I would not be surprised if I fail system tests or whatever. Like why? Like, does this matter? Because for whatever, like symmetry reasons, I feel like this doesn't make sense, right? I guess if this passed, then maybe it makes sense. I just kind of thought I needed it. Okay, no, this doesn't make sense then. I don't know why. I mean, it also might just be like I said, wrong and just pass all the test cases, but oh, no, I'm just dumb because prefix I need. This is actually on this part. Okay, maybe I am just dumb actually. Yeah, okay. Actually, yeah, no. This is symmetric. Or the logic is consistent rather. And I wrote this in a really funky way. This case analysis. It's good that we sort this part out though. Do I need it? maybe. It is way weird. Do I need it? I guess so, right? Because no, maybe not. Yeah, because I thought I needed it because I guess I missed this part, which is a little bit dumb. I didn't miss. This is a legit case that I missed. Because it is saying that if you have something like I don't know how to write it. Something like this, right? And if you do one, just because you do, okay, the first one is a whatever, and then now you have this one. If you do this one, it doesn't mean that you remove the requirement. Maybe let's just say you have, this is a one, right? Because you remove this one, and then you put a one here, it doesn't remove the requirement that you need a one in the future. So you have something like this, 1 1. This does not remove this requirement, right? Because you still need a one, or like in between, because this one is symmetric to this one, so that means that you need a one in between, but this one does not invalidate this one being anything, right? Because this one is still the prefix, and as a result, well, it's the prefix and the suffix, so that if you put a one here, the state doesn't change, right? Because if all these are zeros, and I guess that's all you have to say, is that if all these things are zero, this number is still bigger than this number. So you still need a zero in between, and that's why, okay. So just missing this part. I guess I thought maybe it was the middle bit part, but I guess I actually handled it cleaner than I thought. But I just kind of missed one case, which is a tricky case that I was trying to articulate. But yeah, I think this was a interesting contest. I wish I did better, I suppose, but because I got most of it pretty quickly. Like I knew the idea, right? Like I had 40 minutes to go, and I just didn't come up with that case. Didn't even think about it, honestly, until I was just like, I don't know. I mean, it was more YOLO than anything. I thought I was stuck on the middle digit logic, but I guess well, the funny thing is that because of that middle digit logic, I actually got a wrong answer as a result, because I fixed this, but then I didn't fix the middle digit thing. So I don't know. But yeah, 2 minutes to go in the contest, so we'll just do a quick retro. Q1 easy, I mean fine. Q2, what's Q2 again? Oh yeah, I mean this is just a long, you basically do a sweep, pretty straightforward. This one, I mean, yeah, it's a little bit messy, but not so bad as long as you see the mono stack. Probably could have been a little bit faster, but the stuff is a little bit awkward for sure. Yeah, and this logic just feels yucky. I mean, there is a reason for it, but it still feels yucky. And this one's fine. I mean, I knew what to do, but for 40 minutes, well, I mean, I guess I legitimately missed a case, and I just didn't know how to find this case, right? Because it's just very tricky. And this was that case. Did I already missed it? Okay. Let me just write it out. So then if this was a zero, that's the case, right? That this is supposed to be handling. Yeah. Anyway, yeah. I mean, I enjoyed it. I wish I did better. And I also wish for more wishes, but overall, pretty okay. Not gonna worry about it. I mean, it was a fun problem for sure. It was just frustrating because I mean, it was a legit wrong answer. It's just that I really didn't think about it. And I don't know if there's an easier way to represent it. Like, I wouldn't be surprised if some of the smart people didn't like much shorter code. I still didn't pen it. That's what I was looking for. This definitely does not look like digit DP. I guess it's more base math. I guess a lot of people did not do digit TP. Maybe there's some logic here. Maybe that's why so many people solved this one. Is there anyone else I recognize who's not a cheater? I guess no one did it with digit TP. I don't know that I know this. I mean, this is similar to what I was doing, but for this part, I guess that's the. Maybe there is a way of doing this math, huh? Okay, I mean, maybe I was the only one to do it with digit TP. Oh well. I have to think about the other solution, but I also thought I was way closer to digit TP, so it wasn't like I didn't spend time finding it, so I didn't find it, but or find that particular solution. But yeah. Anyway, all right. That is all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.